Welcome to CadBench. In this video, we are going to see a demo about SolidWorks. So here, in SolidWorks, we will teach you from basics to advanced related on industrial models. The syllabus is framed by industrial experts and then syllabus is also framed based on interviews. In the SolidWorks, what models are going to be covered are part modeling, sheet metal, surface, mold tools, weldments, and then drafting with GD&T. These all topics will be covered. So SolidWorks is mainly used in SPM industries, sheet metal industries, and foundry-based industries. Initially, if you open SolidWorks, this window will be appear. If you want to design a part, you can click part. If you want to assemble it, you can go for assembly. If you want to draft it, means if you want to convert it into 2D from 3D, you can go for drawing. Or else this home page will be appear. In this home page, if you want to create part modeling, you can click this, or else if you want to assemble, you can click this. Here in View All tab, you can access recently saved documents. Around 50 files you can access here, and then you can access recently saved folders also here. First of all, I will explain about the user interface of this SolidWorks. This is called standard menu bar. In the standard menu bar, file menu, edit menu, view menu, insert menu will be there. In file menu, how to open a new drawing sheet, how to open a saved file, how to open a recent saved files, and then how to make drawing from this part, how to make assembly from this part, how to save this part. So all kind of commands will be there. Edit view commands will be appeared in this command manager. This is called as command manager. In this command manager, sketch tab, future tab, surface tab, sheet metal tabs will be there. This is called quick access bar. Here home, new, open, save commands will be appeared in an iconic manner. This is called as future tree manager. In this future tree manager, sketch planes will be there. These sketch planes are used to draw a component. So this is called views header. This is going to useful for zoom in, zoom out command. If you are in zoom out, you can go for zoom to fit. It will be automatically fitted to the screen. If you want to zoom a particular area, you can go for this command. If you want to go for previous zoom state, you can go for this command, and you can get a section view by using this command, and then you can get a view orientation by this view cube, and you can change the view style to wireframe or else hidden lines like that, and you can control what planes need to be shown, what planes need to be hidden, axis need to be shown or not. You can control this. You can edit the appearance of the part also, and you can change the background here also. This is called task pan. In this task pan, already predefined works will be there, called as design library. Here forming tools, futures, assembly parts will be appeared here, and also toolbox will be there. It will be very useful in assembly. You don't need to design every nuts and bolts. Some assembly components will be available here. You can use that. This is called a status bar. In the status bar, what version I am using, what I am doing, I am editing a part, in what unit I am drawing this part, or else in what unit I need to change. You can edit document units also, and you can set your own unit settings also here. You can customize this user interface by using this customize. In this, first we will teach how to constrain a sketch. First of all, sketch model will be covered. How to constrain a sketch. Constraint means in SolidWorks, there will be a sketch status called as underdefined, overdefined, and fully defined. Sketch need to be in fully defined constraint. So how to define a sketch? I will draw a rectangle and show it as a sample. If you want to fully define this, you need to give dimensions and relations. I'm just giving 100 as a dimension and giving 80 as a width. So this rectangle is fully defined now by using this relations and this dimensions. So how to use this trim command, convert command, mirror entities, every sketch tool will be covered here. And in future tabs, all kind of 3D tools will be covered there. In extrude, what is the use of midplane, what is the use of draft, what is the use of thin future. So every tools will be covered. Nook and corner, everything. What is the use of up to vertex, what is the use of up to surface. We will cover from basics to advanced. And we will teach how to use the sweep tool, how to use this loft tool, and how to use this hole wizard tools. So these all tools will be covered in future tab also. Next, sheet metal. In sheet metal, initially we will teach some theoretical topic about sheet metal. What is meant by sheet metal? How much thickness it to be needed? So sheet metal is basically 0 to 6 mm is considered as sheet metal. Up to 6 mm to 12 mm it will be considered as plates. So this is the basic one. I'm choosing my top plane as my sketch plane and drawing a rectangle here and converting this as a base plan. Sheet metal base plan is the first command. After completing this base plans command, we will teach how to use edge flanges, how to use smitter flange, how to use hemming tools, how to use cornering tools, how to fold and unfold, how to get a flat and go on sheet metal, how to use forming tools. Everything will be covered in sheet metal also. After completing sheet metal, we will teach about assembly. In assembly, there are two kind of approaches, top-down approach, bottom-up approach. Both will be covered here. In top-down approach, in assembly area, we will assemble components and then we can design a new part in the assembly area. That is called as top-down approach. In bottom-up approach, we will assemble the components only. We will not design in the assembly area. In assembly also, all kind of mates, from standard mates will be teaching here, advanced mates will be teaching to you, and then mechanical mates also will be teach to you. After teaching the mates, we will teach how to use copy with mates, and how to use assembly features, how to use the toolbox here, how to get a bill of material for this part, how to get an exploded view of this part. So we will teach everything in the assembly module also. After completing this assembly, we will go for drafting. So how to convert a 3D into 2D. Here I am going for file and make drawing from assembly. It will ask for what sheet size I need to be chosen. I am choosing this A3 sheet and then I am placing the views by using this view panel. Here I can convert a 3D model into 2D views. So here all kind of views will be covered. How to use model view, how to use projected view, how to get a section view of a component, how to get a broken section view, how to get a break view, and how to get an alternative position view. Everything will be covered. After completing this, how to use this annotation tools, how to give the dimensions, how to give note, and how to give balloons, and how to use surface finish, how to use Wilmot symbols, and how to use the whole calor, and what is the use of GDNT, how to use geometric tolerance symbol, and how to use datum future. Everything will be teaching here also. And we will teach about tables, how to use whole table, bill of material, revision tables, well tables. Everything will be teaching here. After completing this, we will teach about surface modeling. So surface is mainly used for other CAD files and then plastic component designs. So first I will create a surface. So here I am just extruding the surface. It will work as an extrude command, but it will generate as a surface, not a solid. Surface is an illusion. There will be zero thickness for the surface. So zero thickness means if I apply a material, I can't able to get a weight also. Once I am completing the part modeling, I will teach how to use this evaluate tools also. In this evaluate tools, you can measure, you can get the mass properties, you can get the section properties. In assembly also, we will teach about evaluate tools. In this assembly also, we will teach how to use clearance centrifugation, how to use hole alignment. So everything will be teaching here. So I thought about surfaces used to work in other CAD files, right? So how to save, how to get a other CAD file, or else how to share my SolidWorks file to the Creo user and CAD user. I need to save this document as IGS or step format. You can save this as IGS or else step format. If you open an IGS or step file, it will be like this. I will open a sample file and show it to you. If you open an IGS file, it will be like this. It will be like an imported body. I can't able to get the future tree managing. If I need to work in this file, I need to first break the link or else dissolve the future from the other CAD file, and then I can run future recognize to recognize the future. If I can't able to recognize future, I need to work in surface. Then how to convert a solid body into surface body? If you want to convert a solid body into surface body, you need to just delete a face. If you delete a face, it will be automatically converted into solid from surface. So in surface modeling also, we will teach from A to Z. After completing surface modeling, we will teach how to use mold tools and then how to use Wellmans also. So in SolidWorks, we will teach everything from basics to advanced based on the interviews from industries. So these are the course outcomes. I will show some course outcomes here. You can able to design a hook like this. You can able to design a structural design like this. You can able to assemble like this. So these are the course outcomes. If you have any queries other than this, you can contact us in the below given number, or else you can mail us. Thanks for watching this video.